Hello students, in this video we are going to see transport layer and its services. This transport layer protocol provides various services such as process to process communication, addressing, ICANN ranges, encapsulation and decapsulation, multiplexing and demultiplexing, flow control, error control, and importantly sliding window, congestion control, and also it provides connectionless services and connection oriented services. We will be seeing all these things in this video and in the next videos. Since we have already seen few topics in the previous video, we will see from flow control. Whenever an entity produces items and another entity consumes them, there should be a balance between production and consumption rates. If the items are produced faster than they can be consumed, the consumer can be overwhelmed and may need to discard some items. If the items are produced more slowly than they can be consumed, the consumer must wait and the systems become less efficient. This figure shows that we need at least two cases of flow control. One is from sending transport layer to the sending application layer, and from the receiving transport layer to the sending transport layer. Next, we will see what is pushing and pulling. If the sender delivers items whenever they are produced without a prior request from the consumer, the delivery is referred to as pushing. If the producer delivers the items after the consumer has requested them, then that type of delivery is referred to as pulling. In communication at the transport layer, it deals with four entities, that is sender process, sender transport layer, receiver process, and the receiver transport layer. Next important services provided by transport layer is error control. Reliability can be achieved to add error control services to the transport layer. Error control at the transport layer is responsible for detecting and discarding corrupted packets, keeping track of lost and discarded packets and resending them, recognizing duplicate packets and discarding them, buffering out of order packets until the missing packets arrives. Error control requires that the sending transport layer knows which packet is to be resent and receiving transport layer knows which packet is duplicate or which packet has arrived out of order. In order to make that, this particular error control message uses the concept called as sequence numbers. Each and every message which is being sent will be allocated with a sequence number so that the receiver can know which sequence number has lost during this transaction. Also, the receiver side can send acknowledgement for each and every data it is collected by packets and which is reached safe and sound. Sliding window. The buffer is represented as a set of slices called as sliding window that occupies a part of the allocated blocks at any time. At the sender site, when a packet is sent, the corresponding slice is marked. When all the slices are marked, it means that the buffer is full and no further message can be accepted from the application layer. When an acknowledgement arrives, the corresponding slice is again unmarked. If some consecutive slices from the beginning of the window are unmarked, the window slides over the range of the corresponding sequence numbers to allow more free slices at the end of the window. Here we demonstrate the working of TCP sliding window. We fix up the size of window as 4. So ABCD as the 4 alphabets is being sent from the sender side to the receiver side. After the ABCD alphabets, that is 4 bits received, the receiver will be sending an acknowledgement to the sender side. And after sending the acknowledgement, the receiver will erase the 4 bits, that is they erase the 4 window size being allocated, and it will again ready to accept the next 4 bits. So this work keeps on going and we fix up the retransmit timer as 34 and round trip time as 30 and loss which is being calculated as 0%, and we have demonstrated using the speed as 5. So at a time we can able to send 4 bits from the sender side, the receiver receives it In this animation, we can see the possibilities of errors could happen in TCP sliding window. The first, ABCD is being sent from the sender side to the receiver side, where B is getting lost somewhere else during transmission. So instead of B, A is sending acknowledgement multiple times, that is 4 times, and whereas C and D is not getting any acknowledgement. So the messages are retransmitted from the sender side to the receiver side. So this is one possibility of error could happen. So due to this, definitely there will be a loss of message could happen. Similarly, here we can see that the next 4 bits are being sent, and again the same thing is getting happened. So an important issue in a packet switched network such as internet is congestion. A congestion in a network may occur if the load on the network, number of packets sent to the network, is greater than the capacity of the network, that is, the number of packets the network can handle. Congestion control refers to the mechanisms and techniques that control the congestion and keep the load below the capacity. Congestion in a network or internetwork occurs because routers and switches have queues, buffers that hold the packets before and after processing. A router, for example, has an input queue and an output queue for each interface. In a connectionless service, the source process needs to divide its messages into chunks of data of the size acceptable by the transport layer and deliver them to the transport layer one by one. The transport layer treats each chunk as a single unit without any relation between the chunks. When a chunk arrives from an application layer, the transport layer encapsulates it in a packet and sends it. This figure shows that the client side, the 3 chunks of messages are delivered to the client transport layer in the order of 0, 1 and 2. Because of the extra delay in transportation of the second packet, the delivery of messages at the server is not in order. So they have received it as 0, 2 and 1. If these 3 chunks of data belongs to the same message, the server process may have received a strange message. This situation would be worse if one of the packets were lost. So this connectionless service, there is no flow control, there is no error control, and even there is no congestion control can be effectively implemented in this. In a connection-oriented service, the client and the server first needs to establish a logical connection between themselves. The data exchange can only happen after the connection establishment. After data exchange, the connection needs to be torn down, that is, closed down. At the transport layer, connection-oriented service involves only the last 2 hosts. Fine, we have come to the end of this topic. We will see the next topic in the next video. Thank you.